Hi everyone, so in today's video we're going to be talking about concentration but calculating it in grams per liter. So again, concentration is always going to be your solute divided by your solution. We're talking about our solute in our solution. Our solute is going to be in mass. So the unit would be in grams and our solution is going to be in volume. So the unit would be liters. And this is where you have your gram per liter unit coming in for concentration because it's literally your mass of your solute in grams divided by the volume of your solution in liters. So what we're going to do now is we're going to look at a couple of questions and how to do these calculations. So let's look at the question that we have. What is the concentration of a solution of 2.5 grams of solute, I'm going to highlight this, dissolved in 4.5 liters? So now that we've highlighted the numbers that we have, let's write down our variables and what each of the numbers represent. So we have C, we have M, and we have B. We know that this 2.5 grams of solute represents our mass. So our mass is 2.5 grams. And we know this 4.5 liters represents our volume. So the volume of our solution is 4.5 liters. And as a result, concentration at this moment is X because we don't know what it is and we're looking for it. So our first step is to write down our equation. So we know that our equation is concentration is equal to mass divided by volume. And now our next step is to plug in the numbers. So we replace M with 2.5 grams and we replace V with 4.5 liters. Now I just wanted to highlight something that you'll see that I have written the units. So again, mass 2.5 grams, volume 4.5 liters. It's very good practice to put in the units in your math because it's going to actually help with your overall units in the end. And this is actually not just important when you do concentration calculations, but it's also extremely important when you're doing calculations with respect to dynamic electricity. So now we're going to go ahead and do our division. So we have to do 2.5 divided by 4.5, and we get an answer of 0.56 grams per liter. So in the next question, we're actually going to be working backwards in the sense that we'll be given the concentration and we're going to have to look for the mass of our solute. Okay, so the question that we have is how much mass is required to make a 2.6 liters of a 0.75 gram per liter solution? So same thing, C equals M equals and V equals. So we know that we have our two numbers, 2.5 liters and 0.75 grams per liter. So if the unit, since we know that we're looking for a concentration in grams per liter, the unit G/L should give us an indication that this is our concentration. So we know that our concentration is 0.75 grams per liter. We know that L is a unit for volume, so we have 2.6 liters is representing L, and we don't know our mass, so it's our unknown. Same step as last time, now we write our equation and we plug in what we have. So our equation is concentration is equal to mass over volume, and now we're going to plug in our variables that we have. So we have 0.75 grams per liter equals M divided by 2.6 liters. Now we have to do a little bit of math. Now remember, the opposite of a division is a multiplication. So that means we are multiplying both sides by 2.6 liters, and what you do to one side of the equation, you need to do to the other. So if we do 2.6 times 0.075, we get 1.95 grams is equal to our mass. Now, why is it just grams? Because the liters cancel out the units, and what is remained is grams. So in the next question, we're going to, again, have our concentration and our mass, and we're going to be looking for our volume. And this is usually the part of the concentration questions that people have a little bit more difficulty with, because you have two rearrangements to do, which we'll be seeing in the next slide. Okay, so what volume of water is required to make a 3.75 gram per liter solution with 0.25 grams of solute? So same steps we're going to do. C is equal to, in this case, 3.75 grams per liter. M is equal to 0.25 grams, and V is our unknown. So we'll start again with the equation. C is equal to M divided by V. Now, we're trying to isolate V. So the easiest way to do this is to actually rearrange the equation before you start. So again, we have M divided by V. So what you want to do, the opposite of a division is a multiplication. So we divide both sides, we multiply, both sides by V, which turns into the following. C times V divided by M. But we're not done here, because again, we want to isolate V. So to isolate V, we need to get rid of, you betcha, C. So the opposite of a multiplication is a division, so we divide both sides by C, cancels out on that side, and we get our resulting equation, V is equal to M divided by C. Now, you could have done like we've done before, plug in the numbers in our base equation and then do the rearrangements, but I advise that you rearrange it before because a lot of people forget to do the double steps. Okay, so now now that we have our rearranged equation, we're gonna start plugging in. So V is equal to 0.25 grams divided by 3.75 grams per liter. Just like before, the units gram cancel out, leaving liters left. And we have our volume equal to 0.067 liters, which is also equivalent to 67 milliliters. Now, it makes sense that our volume is this small, considering that in 1 liter of solution, we'd have 3.75 grams. We don't have 3.75 grams in this case. We only have 0.25 grams. I hope this helped, and in the next video, we're going to be talking about percent concentration.